In the last section, we took a look at solving nonlinear systems graphically, and now we're going to take a look at a slightly different approach, which is to solve them algebraically. So here's the steps. So the first step is to write one equation, or you can actually do both, in terms of one of the variables. And we usually write it y equals blank, y equals something. Second step, substitute that expression into the other equation. And what that'll do is it'll create an equation with only one variable in it. And we like one variable equations because step 3, well, we know how to solve them. So solve that one variable equation. And then once you get a solution, we can go on to step 4, which is substitute each of those solutions back into one of the original equations to get the other variable. And finally, check it if you can. If you're allowed a graphing calculator but you have to show your work algebraically, then you can always check it that way. Okay, let's do a few examples. And in this first one, we're going to solve algebraically the system y equals x squared minus 3x minus 5, so that's a quadratic, and 2x minus y equals 5, so that's a linear system, or a straight line. And you'll notice that this first one is already solved for y, so we can just go straight to the substitution step. And so I write the second expression out, 2x minus, but instead of using the y, I'm going to use this long expression over here. And so make sure I have brackets, 3x minus 5, so that's what y is equal to. And now this expression only has x's in it, so I should be able to solve it. So distribute this negative sign and collect like terms, x squared plus 5x, subtract 5, so that's equal to 0. I'll switch all the signs, just divide by -1 or multiply by -1. I get this expression. I'll do this one with factoring since it factors quite nicely, and I get 2 solutions for x. Now I go and take those solutions for x and I plug them back into either of these equations. It doesn't matter which one. Since the first equation is already solved for y, it might actually be easier to use that. So when x is equal to 0, y is equal to 0 squared minus 3 times 0 minus 5. So one solution is 0 and minus 5. And when x is equal to 5, y would be 5 squared minus 3 times 5 minus 5, which is 25, take away 15, take away another 5, which gives me the point 5, So my solutions are 0, -5, and 5. Okay, let's go check this. You could substitute these 2 points into either of these and see that it works. Basically, I've already substituted it into this first equation, so now I can substitute it into the second equation. So if x is 0 and y is -5, you get 2 times 0 minus 5. Does that equal 5? It sure does. And then if I do the same check, 5, I get 2 times 5, take away 5, does that equal 5? 10 take away 5 is 5, and that equals 5. So for sure these are correct. Or you could grab a graphing calculator if you're allowed to, and check these by doing it graphically as well. Okay, let's take a look at one more example. So in this system we'll have x squared minus y equals 1, and x squared minus 2x plus y equals 3. So neither of these are solved for y, so you can choose either of them. I see that this one's already a plus y, whereas this one's minus y. So solving this one for y gives me y equals, and just move the terms to the other side, 3, take away an x squared, add 2x. And so there's an equation in terms of y, and now take this part of that equation and substitute it in for the y in the other equation. So it's x squared take away y, but instead of y I'm going to use 3 minus x squared plus 2x, and that's going to equal 1. And then distributive law, and collect together like terms. So this is -3. If I subtract 1, I'll get -4. And now I can see if I can do anything with this, perhaps factor it. Oops, actually I've made a little mistake. X squared and another x squared is 2x squared. So now I can take out a 2, divide everything by 2, and now I can factor it no problem. If it didn't factor, I'd use quadratic formula, but luckily this one factors, and hopefully most of them will. So there's my two values, and now I can choose either of these to plug them back into. So when x is 2, this first equation will give me 4 take away a y will equal 1. So this is when x is 2. And subtracting 4 will give me negative 3, so y is 3. So one of the points is hopefully 2, 3. And when x is negative 1, I get negative 1 squared minus y equals 1, which is 1 minus y equals 1, subtract 1, and I get y equals 0. So my other point is negative 1, 0. There's my 2 points. You're welcome to check them in the other equation or graphically, and you'll see that they work. Okay, that's it for today.